Anytime you measure temperature, chances are you're using a thermal transducer. A thermometer senses thermal energy and translates it into a signal, the mechanical expansion of mercury in a tube. In the case of a thermograph, which measures temperature over time, the output signal is the movement of a needle. Or an output signal could be represented in digital form. But in all cases, a thermal transducer has thermal energy on the input side and a signal on the output side. Almost any material will change in some way when exposed to heat, either by changing shape or its ability to conduct electricity. Let's look at changing shape. Metals expand when heated. The amount of expansion depends on the amount of heat, but also on the type of metal. If two different metals are heated the same amount, one will expand more than the other. If these two different metals are bonded together, the only way one can expand more than the other is if they bend, with the metal that expands the most on the outside of the curve. This is the bimetallic strip. The most common use of bimetallic strips is in thermostats. The strip is wound into a coil with a mercury switch on the end. Heating or cooling it causes the coil to change its shape. If you have one of these in your room, you might see the strip move just by blowing on it. To measure extremely high temperature environments, a different type of transducer is needed. One of these devices is called a thermocouple, and its origins go back to the careful observations of a clever scientist named Seebeck. In 1882, Seebeck observed a strange phenomenon when he heated a ring made of two different metals. When the heat was applied to the junction of the two metals, an electric current was produced. Any current has a magnetic field, which can be detected with a compass. This is what Seebeck did. This junction of two different metals is the thermocouple. The effect of producing an electric voltage when heated is called the Seebeck effect. The voltage difference produced by the Seebeck effect is related to the temperature difference. This changing voltage from a changing temperature can be easily read by a meter or a gauge. A device similar to the thermocouple is the thermistor. Instead of two metals, the probe has one element carrying a small electric current. When materials are heated, their resistance changes, which changes the current passing through them. This relationship you've seen before in your resistance unit. The temperature changes ρ, the resistivity of the material. The changing current with the changing temperature is the signal. Some thermal transducers can be used to measure other forms of radiation besides heat. Among them are devices used to measure microwave radiation. In the same way that food is heated by microwave radiation, materials are used in transducers that do the same thing. The change in temperature of the material when it absorbs the microwaves changes its electrical resistance, which can then become the output signal. These types of transducers are used to check transmitters for radiation leaks as well as monitor their performance. Thermal transducers provide vital information about areas where fingers and glass thermometers cannot go. Plasmas hotter than the surface of the sun, inside nuclear reactors, and inside technology where thermal energy is at work lifting us into the future. Or something poetic like that.